All right, this is week 4, Math 208, section 4.2, solving a system of equations by substitution. So what does substitution mean? Well, first off, you remember we're solving a system of equations, meaning these two equations represent lines, and we are trying to find where those two lines intersect. But sometimes graphing them is too imprecise, it's too hard. And so we've got this new method called the substitution method, and that's how we are going to find where these two lines intersect. And so what we're going to do is we've got these two lines, and I'm just going to rewrite the equations down here. X plus y is equal to 16, and x equals 3y. Now what substitution means is we see that x is equal to 3y, which means when we go over here, we can replace the x with 3y, and the new equation is this, because we took this x and we replaced it with 3y, so now we have 3y plus y equals 16, and now that equals 4y equals 16, and so dividing both sides by 4 tells us that y is equal to 4. So now that we know that y is equal to 4, we can put 4 into the y. See why it's called substitution? We keep substituting. And wherever we see a y, we're going to replace it with a 4. So this becomes x is equal to 3 times 4, which means x is 12. So now that we know x is 12 and y is 4, that's our ordered pair. So we now know that the two lines intersect at 12, 4, because remember, the first number is always the x-coordinate and the second number is always the y-coordinate. So we know that these two lines cross at 12, 4. Now the cool thing is, if we used Desmos, remember, Desmos is your friend. If we were to graph these two lines, they would cross and intersect right here at 12, 4. Now, one of your lines, oh golly, what is it going to look like? 1/3. It's going to look like this. It's going to be going like this. And then the other line is going to be looking something like this. And then you can see their intersection is right there at 12, 4. So you have a choice. First, you're going to use that substitution method because it's not too hard. But then you can use Desmos to check your answer. And when it's a whole number, Desmos is a really handy tool that will give you this answer. Now, if the answer was like some sort of fraction, Desmos is a little useless. So that's why we have to do the algebra as well as just using Desmos. So here, more of the same. We've got these two equations, so I'm going to start by writing them down. We've got x plus y is equal to 20, and then we have y is equal to negative 5x. So this says wherever we see a y, we can replace it with negative 5x. So that becomes x plus negative 5x equals 20. So you see, I saw the y and I replaced it with a negative 5x. So that ends up being negative 4x equals 20. Dividing both sides by negative 4 gives us x is equal to negative 5. Well, now that we know that x is equal to negative 5, we could insert it over here. We end up with negative 5 times negative 5 is equal to our y. So y is equal to 25, and so that is your ordered pair, negative 5, 25, and that right there is where these two lines intersect. So what's different here is we've got fractions, but it's actually not terribly difficult on this one because they've kind of made everything super easy for us. So I'm going to copy the questions, the two equations, 7x plus 5y is equal to 7/5. And then I've got y is equal to 5x minus 1. So right there, right here, I see that wherever I see a y, I can replace it with the 5x minus 1. So we're going to go over here, and we've got 7x plus, and this is going to be 5 times, and it's going to be 5x minus 1 equals 7/5. So you see, I see a y here, and I replaced it with the 5x minus 1. So right here, we've got a distributive property. We've got 5 times 5x and 5 times negative 1. So this ends up being 7x plus 25x minus 5 equals 7/5. And then we can combine like terms. So this gives us 30x minus 5 is equal to 7/5. And we're going to add 5 to both sides. And so the left side is going to be 30x equals. Now, scratch paper, if I want to add, over here on scratch paper, if I want to add 7/5 plus 5, all right, I'm going to think of that 5 as 5 over 1. And then I'm going to multiply both the numerator and the denominator by 5 to get us a common denominator. So that gives us 25 over 5. And so that, adding those two together, gives me 32/5. So this junk right here, 7/5 plus 5, gives me 32/5. And by the way, I noticed I goofed up over here. 7 plus 25 is actually 32. And so this is 32. All right. So now, what's our next step here? I'm going to multiply both sides by 1 over 32. And when I do that, this 32 and 1 over 32 cancel out, leaving us just with the x. And then over here, this 32 cancels out with that 32, leaving us with 1/5. So x is equal to 1/5. So now that we know x is equal to 1/5, I'm going to go over here and replace it. So I'm going to zoom in here. So we've got x is equal to 1/5. And so 5 times 1/5, the 5's cancel. So that leaves us with 1 minus 1. So y is equal to 0. And so now we know our ordered pair. Our ordered pair becomes 1/5, comma 0. So these two lines intersect at 1/5, 0. Now this is a perfect example where Desmos won't help you because it's a fraction, and Desmos doesn't show fractions. It only shows decimals. So there you go. All right, so we have two lines up here, and we're trying to find where they intersect. So y is equal to 2x plus 1. Really all I'm doing right now is just copying the equations down. And we got 7x equals 11. And this equation right here has already been solved for y. That means we could just replace y with 2x plus 1. So that becomes 5 times 2x plus 1 minus 7x equals 11. And now I'm going to use the distributive property here. So that gives us 10x plus 5 minus 7x equals 11. Combining these like terms gives us 3x plus 5 equals 11. And then we see that we could subtract both sides by 5. And that gives us 3x equals 6. So x equals 2. All right. So now that we know that x equals 2, we can substitute it in up here. So that says y equals 2 times 2 plus 1. And so y is equal to 4 plus 1. So y is equal to 5. And so our ordered pair is 2, comma 5. So here we've got more fractions, and so I'm going to begin by writing those equations. 4x minus 7y equals negative 8, and then we've got x equals 6 minus 1/4 y. So they've already solved for x, which means we can replace x with 6 minus 1/4 y. So I'm going to write that down. So you've got 4 times 6 minus 1/4 y minus 7y equals negative 8. So right here we have the distributive property. So 4 times 6 and then 4 times 1/4 y. So that becomes 24 minus 1y, because 4 times 1/4 is 1. So that's 4 times, that equals 1. So 4 times 1/4 is 1. So it becomes minus 1y. Minus 7y is equal to negative 8. We've got like terms here, so that's 24 minus 8y equals negative 8. And then I'm going to subtract 24 from both sides. So that gives us negative 8y is equal to negative 32. And then dividing both sides by negative 8 gives me y is equal to 4. So now that we know y is equal to 4, we can substitute that into our other equation, and we get x equals 6 minus 1/4 times 4. Well, 1/4 times 4, that's beautiful. That's equal to 1. So it becomes x equals 6 minus 1. So x equals 5. So that is our ordered pair, 5, 4. So that is where these two lines intersect. And because it's a whole number, Desmos would have been nice on this. You just type in these two equations and then see where the lines cross on Desmos. All right, so we're going to find where this, these two lines cross. And you've got x plus 11y equals 29. And you've got 3x plus 5y equals 3. Right now, neither of these equations have been solved for a variable. But this guy's close because he's got just a plain old x. So let's solve for x. And we're going to solve for x by subtracting 11y from both sides. And that gives us x is equal to 29 minus 11y. So there, this tells us that we can now replace the x with 29 minus 11y. So that's going to become 3 times 29 minus 11y plus 5y equals 3. So what I did, I saw the x and I replaced it with 29 minus 11y. And now we're going to kind of focus on this equation for a little bit and solve it. So we've got the distributive property here. So that's going to be 3 times 29 and 3 times negative 11. So this becomes 87 minus 33y plus 5y equals 3. We see some like terms here. So that becomes 87 minus 28y equals 3. And then we want to solve for y. We want to get that y all by itself, so we have to begin by getting rid of the 87. So that leaves us with negative 28y equals negative 84. So now we're going to divide both sides by negative 28, and that ends up being y is equal to 3. So now that we know that y is equal to 3, we can take that and substitute it in right here. So you've got x equals 29 minus 11 times 3. So x is equal to 29 minus 33. So x is equal to negative 4. And that is your ordered pair, negative 4 comma 3. All right, so what does that mean? That means these two lines up here, if we graph them in Desmos, they are going to intersect at negative 4, 3. So that's actually a good one for us to use Desmos with because it's a whole number answers, so we don't have to estimate with fractions or decimals. That's perfect. So Desmos really would be a good one on this one. So we're going to continue solving this system of equations, and I'm going to begin by writing both of our equations. And 3x minus 4y equals negative 22. And again, neither of these equations have been solved for a variable. So I'm going to solve one of them for a variable, and it doesn't matter which one you solve. And they're both ugly, so let's solve for this one. And let's solve for x, I guess. So we're going to get x all by itself. So we're going to subtract by 5y both sides. So that ends up being 7x is equal to 49 minus 5y. And then we're going to divide by 7, which means everything has to be divided by 7. That means x is equal to 7 minus 5/7 y. Okay, so there is our solution for x. So now we're going to go up here and we're going to replace x with 7 minus, right here, 7 minus 5/7 y. So that becomes 3 times 7 minus 5/7 y minus 4y equals negative 22. So now we have a little distributive property right here. That's not so bad. So that becomes 21 minus 15/7 y minus 4y equals negative 22. Now we need to combine these like terms right here. So that's basically, you've got a negative minus a negative. So really, we need to add these numbers and just stick on a negative sign. So we know it's going to be 21 minus, but now let's go over on scratch paper and let's add 15/7 plus 4. All right. Now, we know that 4 is really 4 over 1, so we can replace 4 over 1 with 28 over 7 because 28 over 7 is still equal to 4. So now we have a common denominator. So 15 plus 28 is 30, 43, 43/7. All right, so now we go back over here. So this is minus 43/7 y is equal to negative 22. And so now we're going to subtract 21 from both sides. And so we end up with negative 43/7 y is equal to negative 43. And we can solve this in one nice giant step. We're going to multiply by negative 7/43. Negative 7/43. And that makes these two fractions go away, leaving us with just 1. And over here, the negative 43 cancels out with the 43, and that gives us positive 7. Now, why is it positive 7? It's positive 7 because a negative times a negative is a positive. So we know that this answer has to be a positive 7. So there you go. So y is equal to positive 7. So that means we could go to this equation and replace y with positive 7. So x equals 7 minus 5/7 times 7 over 1. Because I just replaced that y with 7. And so this 7 cancels with this 7. So we end up with x is equal to 7 minus 5. So x is equal to 2. So x is equal to 2, y is equal to 7, And that tells us that the solution is 2, 7. So these two lines intersect at 2, 7, and Desmos would have been a great tool for this problem. All right, so we've got another series of system of equations. So we've got 3x minus 9y equals 3, and we've got negative 5x plus 15y equals negative 5. Neither of these equations are solved for a particular variable, so let's take this one and solve for x. So I'm going to make this kind of go fast. That becomes 3x equals 9y plus 3. Now I'm going to divide everything by 3. And so that leaves us x is equal to 3y plus 1. So now I'm going to replace that into this equation. So that ends up being negative 5 times 3y plus 1 plus 15y equals negative 5. So we have a little bit of distributive property here. So that ends up being negative 15y minus 5 plus 15y equals negative 5. And we see that these guys equal 0, so this guy cancels out with this guy, so we end up with this really interesting equation, which is negative 5 equals negative 5. Since that is a true statement, that means these two lines have an infinite number of solutions because they are the same line. They coincide. So if we were to graph these two lines on a coordinate grid, I don't know exactly what they would look like, but I can tell you that they are going to coincide. So like one line is going to look like that, and the other line is going to be directly on top of it. So they're the same line. And that's what happens. That's how you know when you get a true statement here. Negative 5 equals negative 5, or 7 equals 7. Something true, that means they are the same line. All right, so let's keep going. So we've got a system of equations. We've got 2x minus 8y equals 2, and we've got x plus 4y equals 0. This is really close to being solved for x, so I'm going to solve for x, and I get x is equal to negative 4y, so that means I can replace the x with the negative 4y, so I end up with 2 times negative 4y minus 8y equals 2, and then so this becomes negative 8y minus 8y equals 2. And so this ends up equaling negative 16y equals 2. And I'm going to divide both sides by negative 16. So we end up with y is equal to negative 1/8. So now that y is equal to negative 1/8, you substitute that in over here, and you end up with x is equal to negative 4 times negative 1/8. Well, we know that the answer is going to be positive because negative times a negative is positive. So this ends up being 4/8, which is equal to 1/2. So x is equal to 1/2, and there is your ordered pair of where these two lines intersect. They intersect at 1/2 and negative 1/8. So this is a problem, a perfect example where Desmos would not really help you much because your answer is fractions. It's an estimation. You would have to estimate based on Desmos because Desmos only really handles whole numbers really well. And the last equation, series of equations, this is kind of an interesting one because this says 6a is equal to 3 minus b, And this, the other one is 6a is equal to 2 minus b. So that means they're both equal to 6a. So that means we can combine these and say 3 minus b is equal to 2 minus b. And then solving, we can add b to both sides because we want to, get rid of the b's. And so that ends up equaling 3 equals 2. Well, is that a true story? No, that's not a true story. That's a false story. So what that tells us is, that tells us that there are no solutions in this system of linear equations, meaning those two lines do not intersect.